The title is Automating Production Optimization, and I'm going to do it from a standards perspective, mostly using MTConnect, but there's a lot of other ones. The other day, I was trolling the internet, and I saw how to make one of these, and I was like, oh, that's so cool. I got to do one. But going into my talk, the word optimization, I told my wife I'm giving a talk on optimization.
Let you wander around.
But I'll get feedback in my ear. Oh, okay. I can hear myself. Think. So I told her, oh, I'm giving a talk on optimization. And she went, you? Optimization? What, are you kidding? You can't optimize anything. And then she went, oh, that's a really cool term. I think I'm going to go into work and use it. I'm going to optimize. I forgot what she said, but something. But in this case, optimization, I think there are other terms like Kaizen, sustainability, lean, continuous improvement, et cetera, that are similar to optimize but are not nearly as cool mathematically sounding. And the thumbnail of this talk is talking about the work we're doing here at NIST, which is automating optimization, and doing that by leveraging automated data acquisition, which we're seeing somewhat taking over in manufacturing, automated modeling generated from the way the factory floor is set up, kind of post-mortem. You already have a factory and you want to build the model, as opposed to a greenfield where you build it beforehand, like you see a lot in discrete event simulation. And then the automated analysis. I found this slide on the internet somewhere, and these are the steps in optimizing. So the first step would be that you got to measure, then you got to build a model, you got to analyze it to get some knowledge, and then you got to optimize it. And the Kool-Aid here, if you're drinking my Kool-Aid, is automating this process. Yeah. But let's keep it real here. It's kind of my goal. How much is it going to cost to do all this? Is it really worth it? If you don't get all the way, what have you gained? If I had this form of model, does it give me any insight? Is that enough? How much is it going to cost to do all this? Is it timely? A lot of times we did a project trying to do the discrete event simulation of casting. Took forever. That's a problem. And it's not timely. And then another thing, when you're in this area of analytics, is accuracy important, or are flashy graphics enough? I mean, that's kind of one of those things that you have to think about. And it's all based on garbage in, garbage out. If you're not getting good data into a good model, you're not making good analytics. And the reality of it is, even if you have some of this automated stuff, there's always going to be a bottleneck. And you might not change your floor only in a crisis. I don't know if anybody's read this book by Goldratt. It was recommended to me by somebody at GM. It's kind of like the Industrial Management Bible. It's a true story about a guy had 3 months to save his factory, and he'd had all kind of personal problems and all this going on. It's pretty interesting. I recommend it. But what I would say is that we're going to say standards to the rescue, okay? I should have put a Kool-Aid thing there. Okay, this is the standard ISO 95 MOM model. And I'll be darned if I can remember what MOM is, but it's your usual management operations model, of which most of the low-level manufacturing is down here, and then you at the MES level, you organize it all up here. So what we're mostly looking at is the optimization of modeling this, automating this modeling to improve this. Does that make sense? So if you flatten that out, you've got all these ISA elements, and you got to measure them, and you build a production model, and then you analyze. And the kind of things you're looking at are costs, constraints, scenarios, risk. And these are some of the primary tools. Like one of the things, I was working with George Arenas at GM, and they're looking at energy and the risk. What happens, is it cheaper to use gas or electricity? Well, they, in a casting facility to make the molten aluminum, they were using natural gas, but Katrina came and they couldn't get their natural gas. So that's a risk that they now no longer have because they can take care of it. But those are the kind of things. What happens to the fluctuations of prices and things. So see, these are some of the kind of analysis things that you might want to do and be prepared as opposed to last minute or after the fact. I would say that when you're modeling, one size does not fit all. And right now, we're looking kind of, these are the easiest to model because they don't change much. These are totally independent, but somehow you got to build a model. Now I'll go into just the brief issues with each of the areas. The measure is kind of fundamental to smarter understanding. I mean, if you can't measure it, you're just guessing. And of course, there are measurement issues, precision and accuracy. Right now, at least in machine shops, it's still islands of automation. So you have all these beautiful, expensive equipment sitting out there, and you can't do much with them. And here's kind of a litany of things related to measurement. No data, which is kind of the island of automation. Big data, bad data, which is embedded in big data. Incompatible data, so that as it's moving down the stream, you've got to translate from one to another, and every time you do a translation, you inject errors. And then, of course, what data do you want? If you have a terabyte, what do you really want to look at? And I would point out that AMT, and I don't remember if it was just Paul Warndorf or I read this, I do know modern manufacturing shops, it was like 11% of people who responded to a survey do actual machine performance monitoring, to collect data. So, and that's not with a clipboard, I don't think. But some still do. I mean, they'll do it to get accurate data. This was in Modern Machine Shop, No Machine Left Behind. I really love the title. One of the issues with MTConnect has been, it is really hard. Sid can tell you this. It's been really hard to implement all the machines. There's such a variety, and a lot of them are closed, and versioning, and even ones that support it don't support it. Mazak says they do, but you go to the supplier, and the supplier goes, what's MTConnect? And it's a kind of a, it still hasn't quite taken off the way it could. So why don't they just bundle MTConnect in with the controller? But they don't. So Nat Frampton and Real-Time Development, Memex, and Nexus America, which are both Canadian companies, have some solutions for that. The Hall effect sensor, where you just clamp on onto the power line and generate an understanding of how your machine is operating, is pretty cool.
John, is that just to tell whether it's running or not, or is that kind of like?
They can tell running, not running, machining, not machining, and maybe faulted.
Okay.
That's not, everything in the world, but it's certainly better than nothing. Pardon?
It's a useful hack.
It's pretty clever.
Yeah.
And you got power if you want to read the power of how much you're using. Okay, now we'll talk a little bit about modeling, very briefly. There's a lot of ways to model. Empirically, most people just build a dashboard and go, oh, there's a lot of red on here. That's not good. Or you can use some KPIs, key performance indicators, to try and understand the performance of your shop. These are simplistic modeling tools. Now, a more complex model would be stochastic and discrete event simulation, where you build a complete model and then you randomize how, using actually the KPI for like cycle time and fault time, you randomize how it works, and then you try and understand your bottlenecks and your performance and things like that. And that you could probably, you could move towards optimization if you run multiple discrete event simulations in a Monte Carlo. And you could go old school and use some sort of linear programming with a objective function. But the general form for DES is what we're looking at. You lay out the machines in the plant, and generally what you get are digital blueprints. You know, you get AutoCAD, and it's just boxes and stuff. There's no semantic intent telling you, oh, hey, you know, this is actually a machine here, and it has this much power or something. So it's very hard to get the information out of here. I think the U.S. CAR is working on improving having building blocks in AutoCAD so that you could pull this information out to automatically put it into a discrete event simulation model. But that could take a while. I know this is a big headache. The sequence of then you got to put the sequence of operations, and for each step you need cycle time, fault, block, starve, time to recovery. So all this data, all this information relies on being able to measure it properly. If you're not measuring it properly, it's garbage in, garbage out. So why would you spend all that time and energy to get garbage answers, right? So analyze. So here's once you have a model, what are you going to analyze? So here's a list of some costs, constraints, risk, efficiency, and KPI. That's kind of the current buzzwords for dealing with understanding what your outputs of your analysis. This is just a shopping list. One of the issues, though, with KPI is, okay, it's like a car dashboard says service engine soon or check engine light. That's a KPI indicator. It tells you things are bad, but it doesn't tell you what's wrong. So it's worse in a factory because there could be thousands of things that can contribute to poor throughput. So just having the number is not enough, and you really need to work backwards on that. We're studying that too. And then optimize. It's kind of like sensitivity analysis and Monte Carlo. So you need to modify the inputs and assess the outputs. And right now, it appears to me, from what I can tell, what-if analysis is very ad hoc. There's no standard for doing the sensitivity descriptions. And, you know, these objective functions and sensitivity parameters, we're going to try and work on formalizing them. But some of the things that you want to study are downtime, throughput, capacity, budget, costing, sustainability. Do I need new equipment? And then at a low level, which is outside my, you know, how well is my machine actually performing based on what it says it's performing or could perform to. Okay, now it's time for some standards talk. Shop floor to top floor integration. Right, Sid? Been there, done that. But what we want is to make it painless and seamless and whatever. And here's some of the players. So you measure it, and you measure it out with OPC. I'm going to skip the field buses as a way of measuring. I'll go because I want to talk about factory integration, which clearly, if you just use the PLCs and factory networks, you could probably just put it in a SQL server and be just as well off. But some of them here are MTConnect, OPC UA, OPC DA, the old school COM. Then you got to filter it and get out the bad data. Possibly you have to translate it into another format. Then you want to go into possibly a SQL database, Oracle. And I'm going to talk about CMSD. This is a way to develop descriptions to do simulations. And the automation ML is the big European autocar solution for merging process and product information to automate automation so that automating optimization is a byproduct of automating automation. They do that in XML. And they're using PLC Open. I have a slide on that. Then, of course, the cost and constraints, generate KPI and statistics. And I left open the optimize because there's actually a KPI standard. I didn't put it in there. this is supposed to be about standards. Oh, and I didn't even talk about down here at PLC Open, MTConnect. These are information models of ways to the ways to interpret your data on your device. Sorry, I missed that. Should have done that first. So here's a question I get asked all the time. What's the difference between OPC UA and MTConnect? It's a good question, because why do we need both of them? We probably don't need both of them, but they kind of serve two different purposes. And to understand the answer, sort of had this high-level view of how these information models are kind of like where they work. And an application, it's kind of high level, it's device function, configuration, kind of metadata related. Communication deals with your I/O kind of like stuff. Like OPC is really hardcore at this level. The kinds of ways, it allows you to do all kinds of different types of I/O. And then the communication protocol. Are you just using TCP/IP sockets or RCP or HTTP? And then the wire protocol, whether it's Ethernet or some other field bus with power. So here's an integration comparison we did for looking at robotics integration. I just put MMS up there as a kind of a, for all you old timers. I don't see any old timers in here. So, but OPC COM does not have an application domain. It relies on other people to supply that, and it uses a lot of Microsoft technology, IDL, and things like that. It has all the I/O modeling built in Microsoft IDL, and then it uses COM, DCOM /RPC to do the communication. UA, again, does not have an application domain, and it's data handling plus a lot of OPC-specific modeling. And they've modified TCP, changing layer 7 to allow, what would you call it, connections, longer connections than are generally allowed in HTTP for event callbacks. And they also have XML proxy technology. I would say the adoption of UA has been very slow. It's a pretty, I don't want to badmouth it too much. It's been very slow to take off in the US. They have another solution. It's still Microsoft-based. They have this OPC XI to kind of replace some of the DCOM headaches, the DCOM nightmares. But it relies on Microsoft technology. Well, UA separates it. Yeah, this one is not. I meant this one. There's one in between step that people have not rushed to this because there's a lot of issues. They've had performance. You hook it up and it works. I mean, as long, yeah, if someone like me can understand COM, DCOM, that's a selling point. Now, your OPC UA, they redid the modeling, they redid this, they redid that, and I have a slide. I'm working MTConnect OPC UA companion, so I actually kind of understand it a little better, but it's pretty complicated. So MTConnect now, they actually have information models for machine tools, based on ISO 13399. Sensors, they've added sensors. Robots, I don't know, I have that in there. And they allow third-party schemas. So one of the key concepts is this asset. It's something not in the core MTConnect spec that, where you have this real-time update of information. It's an asset. It's kind of like a tool, the description of a tool that you're able to pull out. Or maybe you have a quality report you want to pull out. They're looking at QIF, Quality Information Framework, of which a lot of work is being done at NIST, and it's based out of the DMS standards organization. And let's see here. So there's a lot of possibility in here. We're also looking maybe slipping in a little B2 MML in here if we can, because it would be nice to integrate into the enterprise a little better. Most of the communication model, the data is done by XML streams. There's also XML asset and XML probe. And it uses HTTP with a REST client. So it's pretty polling driven. The way they get around the sampling issue is that you can be the device can be updating at a millisecond, and then every second you'd say, let's say 10 milliseconds. Every second you get 100 readings at one poll. So that's how to get around that issue. At NIST and with some of the MTConnect folks, we're looking at integrating ROS. It's the Willow Creek implementation of a robot operating system. And there's an industrial robot operating system that Southwest Research has been working on, and we're trying to integrate that with what we call MTConnect. But it has information models at this level, and then they have their own way of doing the messaging, the communication, excuse me. And then, of course, there's PLC Open, and this automation ML uses PLC Open and some other things, and they're XML based, and they intend to rely on OPC UA as the underlying communication. Okay, brief tutorial on OPC UA. So OPC UA has a root, it has views, actual instance of objects, types, which are kind of like your classes in Java and C++, and objects would be instances of those classes, and then the low-level data types like real, integer, and string. So this is a mapping of MTConnect into OPC UA, and in it, I can't really see, it's pretty small print over there, huh? So for the views of MTConnect, you get a probe, which is, okay, give me your description of your configuration. Okay, I've got 3 axes. These are the data items under each. I have a controller, and I'll give you the part program name and the block. Okay, then there's a, can't even see what that says. Oh, current. That's a generic way. Just give me all your data at once. Then there's XPath. It's really streams, but it's a byproduct of XPath. So you can go into the XML tree and pull out the information you want in 2 ways. You can prune the tree and get it this way. So there's 2 ways of doing it. Within the data model, information model, and then over time. And then assets, which, as I mentioned, kind of give you static information like tooling, hopefully parts, quality information, and things like that. So, okay, now that's the views. And that's the concept in OPC UA, that the server has different views. In the traditional one, I guess they have the browsing view and the data view. Now the types in MTConnect, they're the object types of, you have devices, and inside you have device, and then you have components, and then you have subcomponents, and in these subcomponents you have controllers, axes, and variations on these things, and data items and samples. Let's see, OPC, they have variables, and that maps into data item types in MTConnect. And MTConnect has sample type, event type, condition type, sensor type. Sensor and sample are pretty similar, except sensors allow configuration information and calibration information, error types, and asset types. And then, of course, in XML, you have attributes, which are called properties in OPC UA. So this low level is just mapping XSD types into OPC UA types. So that's kind of what goes there. Here's an actual instance in OPC UA of MTConnect. So here's a Mazak, and now we're just looking at the instances where we have one device, multiple components, and the component of axes has these data items, and the controller has these 2 data items, of which, actually, these are also components, and these are the data items, the green. And I see the door. There's got a door, huh? Important, open and closed. The cutting edge state of MTConnect are these asset types where a lot of the new work is coming in. So they separated out the cutting technology, sort of like the model archetype of the tool from the actual tooling data, the toolware stuff. And so the actual instantaneous toolware and certain small subset is held in the latest data. Whereas if you want to get the actual picture of the tool, you have to use it as an asset. And this was able to be done because we could map ISO 13399 in an XML schema, although they were ready to pass Part 21 through XML as a blob. But it will be, or it is compliant with STEP Part 28, the XML. So the nice thing that made it easy with 13399 is they only had like one level of inheritance. So there wasn't, when you try and map multiple super level inheritance into XML, it gets messy. And right now, there's been a push whenever QIF, this is the quality, I'll have a slide on this, the quality information standard is done. It'll be as part of the an asset, so you can do quality reporting inside of a machine, be it a CMM or a CNC. And we're looking, right now we're exploring B2MML, the ISO 95 model, as part of this part that you would pass in and out as assets. There's some work on MTConnect inter-device communication, and it's called read-read for purposes I will tell anybody who asks me offline later. And what's that? Thank you, Dave. Good, yeah, that would really screw me, wouldn't it? Remind me when I'm about to put my foot in my mouth. So they've done bar feeders and CNCs, and they demonstrated that at IMTS 2012. And they've got very good performance. Basically, it's like a mailbox with two agents communicating. And then we're working on robot and CNC, and that's a NIST-sponsored activity. Sensors were added, and right now we're pushing hard on this part/traceability, which would fit nicely into optimization. And I don't know why this particular item, this KPI standard is there, but that would be something that would be of interest in, kind of information coming out of your machine. Give two quick slides on quality information framework while I'm here. It's supposed to be a standard coming up in a month or so, at least the first release. But it's got a whole bunch of schemas for working out the life cycle of kind of shop floor quality. They are working with going upstream to get some of the CAD geometry stuff and the tolerancing information. But anyway, this is the whole, it's a flow chart. I mean, you can, right now they're concentrating on quality planning and quality reporting. The measurement execution is done by DEMIS, which is the inspection language. And when you say inspection program, it tells you kind of, like given the amount of tolerance, how many points should I actually generate to inspect to get the assurance that I'm inspecting have a guaranteed inspection that would be reliable for that part. Here's another snazzy PowerPoint that I didn't do. But at IMT, in case you weren't at IMTS 2012, last September, there was a demo using quality information framework that used mostly results, and I'm not sure if it used plans. I don't even see plans. But what they did is they have parts, and they want to generate first article inspection reports, part of the AS 9100 series of quality standards. AS, isn't that aeronautical standards, AS? But anyway, the idea is to automate this whole process and have electronic, distribution of this information, which it is not normally now. And something like this is useful for, you get a part and trying to determine whether it's counterfeit or not, or something like that, or it's intolerance. But mostly, it's for verifying the first time you made a part that it's accurate. I mentioned ISO 22400. This is an ISO standard, another European car maker standard. Is a German standard that they're trying to push through ISO. I personally think it's pretty clever. It basically handles how to understand the utilization on a piece of equipment, and this is it. This is how they break it down. Over the course of a day, plan time, plan busy, blah blah blah, and they standardize this. And as I mentioned before, KPI are metrics, not solutions. So you get a KPI, you're not. I guess if you can see that you got 99% yield, you'd be pretty happy. You wouldn't want to have to do anything. But if you had 99 and went to 96, you go, hey, what's going on here? Or if you had 50, you go, hey, what gives? So. The what? This one up here, the AS? Basically, this is it. And then they have a whole bunch of KPI for quality, performance, and utility. OEE, including quality, and environmental sustainability measurements based on a piece of equipment in a factory over the course of mostly a day. It might be a longer time frame. But as you can see, they map it out pretty well. And because I've had some previous KPIs that are a little more ad hoc. This is a pretty systematic approach to understanding how to do it. Now, AMT supposedly has some standardized terminology, because you can't just use the word utilization. That's kind of like a contract word that, a machine will adhere to this utilization. Then it's fighting words if you don't meet it, and suing words. So I don't know how this fits in with that, but that's not my role to understand that. But you understand how these terms can be important and can lead to litigation if they're misinterpreted. And for example, one of the things is OEE. People use that term right and left, but the real OEE definition from this standard and most standards it incorporates quality in determining the overall equipment effectiveness. And most people don't add that. They're just computing utilization, but they use the term OEE. It's implicit in OEE, but people don't usually measure it very well when they compute the area. Mostly they just figure uptime, downtime, and but a lot of good parts, bad parts is determined downstream, and was it that machine that caused the problem? So it's kind of forgotten. So we've worked out a mapping of, here's some of the ISO standard terms mapped out in like what you would do in MTConnect to map into them. Like good parts, scrap. So there's MTConnect has a lot of the basic data. I'm not gonna. Something we're trying to work out is ISO 95, how to integrate that into traceability in part through a shop floor. It's pretty difficult in that most of the time machines don't really understand that they're part of a job sequence, and they are one operation within a long chain of operations. So it'll be a tough nut to crack. But anyway, using ISO 95, I didn't realize this, but they had added a whole bunch of standards for, they call it transaction-based information to the enterprise. And this B2MML, this should be down here somehow. I don't know how it popped up. Oh. I guess I double clicked. But the B2 MML is an XML implementation of the ISO 95 standards. So it's freely available. So here's the slide saying what it does. And here's their schemas. And it's freely available, which is very nice. It supports all 95 and 88. Only thing I can say is it's been out there a long time. I don't know what the acceptance rate of it is. And for discrete parts people, they use the word material instead of part a lot, so it's a little confusing. I don't know if people would get over that. But it's an issue. But it's all there. And so, I mean, trying to understand how a part moves as a job through a factory, which is important for traceability for the FAA or for the FDA or whatever. They have, right. Yeah, I mean, you might as well leverage something that's got something behind it. I don't know, I can't think of the term to describe. It's got some pull and leverage, no doubt. And when we talked about this, people were like, because the small discrete guys were like, yeah, the little marketers or the little providers like, yeah, sure. It's a bigger pool, right? It's a big pool, ISO 95, because a lot of people adopt it even if they're not batch, because it really was batch-driven, 88, if they're just process-driven. So, now here's something that was done through NIST, Core Manufacturing Simulation. It's sort of also based on B2 MML. I found this picture on somebody's latest paper and just cut and pasted in here. I didn't attribute it yet. Bad me. But it's a way for taking data from a factory floor, putting it into XML, and then feeding it into a discrete event simulation. And these are the major components. One of the nice things that was looking at is the way it'll handle layouts, whereas B2MML is not really at that level. It's more about where things are located. So we are looking at using this as a middleware glue for trying to automate automation or automate optimization, so that we take all the data and then, based on building some model also from the factory floor using MTConnect, because if I know where all the machines are, I should know what they are and what kind they are, and then I can build this CMSD model. The hard part right now using MTConnect is there's no way to really track parts through the factory. So you would need either an MES or ERP system, and usually in the real world, the ERP systems are locked down and only certain people are allowed access to that. So this, so far, this has worked out well, but I do have to look at B2MML since it's has a higher penetration rate of acceptance, I think. I was talking with Tom Scotton, and they use CMSD to do some automated optimization using value stream mapping. They use this product EVSIM, CMSD, and they have an MTConnect factory floor data, kind of how I described it. You can get layout information if you tweak MTConnect a little bit, and they get real data. So this is sort of what they do. I don't even know what storm layout optimization module is, but hey, that sounds good to me. And in their slide, their CCAT, for background, is a Connecticut Center for Advanced Technology in Connecticut, in Hartford. It's on the UTRC, United Technologies campus, and they've given them some land, and they do research for all the aeronautic companies, most of the aeronautic companies up there. There's Sikorsky and UTRC and a couple others. So they do have a lot, and of course the suppliers. So they have a lot of companies. They have been trying to sell this to NIST MEP, but they were getting a deaf ear. But they were able to show improvements. Now, I mean, I wouldn't stake my life on these numbers, but these guys are pretty upfront, and the stuff they're doing is pretty clever. And we're heading, some research we're doing at NIST is heading in this way. And one of the guys that was at CCAT went to this company. Maybe he can give us the value stream mapping. Quick slide on RO, robot, operating system, industrial, and MTConnect. Like I said, NIST sponsored. There's not much to say except that it exploits a well-established base of robot technology, getting it out of just sort of standalone mode and taking it into a factory, connectivity into the factory. And then the big issues are the high-speed performance that you would expect and reliability. Can it be done with MTConnect to control two devices simultaneously? And if you believe Will Sobel, yes, it can be done. This is almost my last slide. I have not fully explored Automation ML. It's been out a few years. But they are trying to marry part production and process design. And their motto is automating automation, which is also MEMX's motto. And they're trying to solve this laying out the machines from digital blueprints. They want it all understood. They expect to use PLC open. It's all going to be XML based. These are their concept of how to translate from all the XML representations. I'll go into that last. But they're using, their standard is IEC 62422. Obviously, I grabbed it from the German site because I have no idea what that says. But they're using Collada, which is a open source graphics package. It has geometry and kinematics. PLC Open, which is now, of course, interchangeable as the fundamental building block. So I would assume it's more process industry driven at the beginning. And they use XML formatting for whenever possible. And the interesting thing about this is they looked at STEP and decided to go to XML RDFs. I don't know enough about RDFs, but it's a way, it's kind of the include problem in programming. You know, how do you keep including things and keeping them unique and name spacing? So it's a name spacing kind of thing, and they use RDF to do this, and then they build the way to go from product to product. The European car makers are behind that. And that's it.